Okay, guys, so as promised, I'm going to just do a quick little video about kind of the same stuff that you saw in the review. So number one, you should be able to classify triangles by sides and angles. So let me just throw some things up here real quick. Um, Okay, so if I were to classify these, the first guy here would be an obtuse triangle. That's deals with angles. It's obtuse, and all three sides are different, so it would be an obtuse scalene triangle. This guy, let me put in some more information. Okay, so this guy would be right because of the angle, and also scalene. So this would be right scalene. And this last one, they all appear to be acute because nobody appears to be 90 or more. And there are two sides the same. So this would be isosceles, acute isosceles. Okay, so that's just naming those. Okay, polygons. We're also going to be asked to identify polygons. Remember, let's see, draw some different polygons here. We'll go with that. Okay, so first of all, I could tell you whether these are concave or convex. Remember, convex is when, or concave actually, is when it kind of caves in on itself, or you could connect two of the vertices and make a connection that's outside of the circle. So like this guy is convex, and this guy is convex. The others are oops, I totally did that backwards. Sorry. These guys are concave because they cave in on themselves. So concave. And then these guys are convex. These are the normal kinds of polygons that we work with in class. So concave, and then if I wanted to do them by the number of sides, let's see, this one's got 1, 2, 3, 4, 5, 6, 7, 8. So this would be a concave octagon. This would be 1, 2, 3, 4, 5, a concave pentagon. 1, 2, 3, 4, 5, 6. This would be a convex hexagon. And 1, 2, 3, 4, 5, another pentagon, a convex pentagon. So if I ask you to identify them by the number of sides, you can do that for pentagon, octagon, hexagon, decagon, nonagon, septagon. Make sure you know all of them up through 10. And then after that, you can just use, like I said, if there are 15 sides, you can say like, it's a 15gon. Okay. All right. How about, what if I said, find the interior angle measure of a regular, that's important. Let's do a regular 12gon. So instead of saying a pentagon or a decagon, maybe I give you 12. So first of all, interior angles are not, this is not the same as the interior sum. Interior sum is when you like take n minus 2 times 180. That's not what we're doing here. This is actually, I want one little angle in that, I want one little interior angle of that shape, right? Okay, so we actually find the exterior angle first. And remember, exterior angles are found by doing 360 divided by the number of sides. So let's see, my exterior angle would be equal to 360 divided by 12, which is 30. So now this is not the interior, it's the exterior. But remember, exteriors and interiors add up to 180. So once you get the exterior angle, you can go 180 minus 30, 150. So 150 degrees is the interior angle for a regular 12gon. That's the hardest one. If I just straight up give you, if I say find an exterior angle of a, let's do, of a 30gon, that's easy. Exterior angle is straight up the formula. 360 divided by 30, boom, 12. So each little exterior angle is 12. If I tell you that the measure of the interior angle is, let's see, 150 degrees, and I want you to find the number of sides. Okay? So this time you know the interior angle. The first thing I would do, go to that exterior angle. So if the interior is 150, that means the exterior has to be 30, because remember they add up to 180. And then remember, your formula for number of sides is always 360 divided by the exterior. So if you're trying to find number of sides, it's 360 over exterior. So then I'd have 360. I now know my exterior is 30, so I get 12. So that would be a 12 gon. So it's actually the one that we did up here. Okay. Okay, so then after that, you had diagrams that used exterior angles of triangles. And this was, I think, maybe one of the harder ones for you guys, for some of you guys. So we'll put a Q there and maybe a Z out here. Okay, and maybe we've got like, let's see, we'll do 5x plus 10. We'll do 3x plus 8 and maybe x plus 20. Okay, so in this case, some people want to try to add these three things up to 180, but they're not the three angles inside the triangle. In fact, this is the exterior angle to that triangle, right? And for a triangle, we said that the exterior angle is equal to the sum of the two remote interior angles. So, meaning don't use the one next to it, but the other two angles inside the triangle should add up to the exterior. So again, the exterior angle is equal to the sum of the remote, that just means not next to, interior angles. So let's see. So my exterior angle is 5x plus 10. My two remote, not next to, interiors of my triangle are x plus 20 and 3x plus 8. So I get 4x plus 28 and 5x plus 10, and then I solve and I get x equals, looks like 18. Okay, so then I could plug stuff back in. My picture is not to scale, which is fine. So let's see. So there's x is 18, but maybe they want the measure of angle P. Most of you could do that part. You just plug 18 in. So 18 plus 20, 38, no problem. It's this. What if I ask you for the measure of angle PQZ? Some of you can't identify that angle, so the easiest way to just follow it. P to Q to Z is this guy. It's actually just asking for that. So instead of 5x, I'm going to do 5 times 18 plus 10, and as it works out, I get 100. So I know that this looks acute, but you can't assume it. So it's okay that it comes out to 100. Okay. Okay, so another one that was, I think, quite easier that we would solve would maybe be something like this, where I would give you the measures of the angles inside of a triangle. And maybe I'll do, let's see, and we'll just do x. Okay, so then A, B, C. Okay, so maybe I want x, and then maybe I want the measure of angle B. Okay, so this one you can add them up, and so I end up with, let's see, actually let's make this 2x. So I can add them up, so I have 2x minus 10 plus 2x plus x plus 40. They are all the interior angles, so they should add up to 180. So I end up with 5x plus 30 equals 180, or 5x equals 150, so x is 30. So now we have 30, and then if we want b, we can just plug 30 in. So 30 plus 40 is 70. So that one's a pretty easy one. Okay, we just have a couple more. We have the isosceles triangle theorem. This one got some of you. Isosceles triangles, the easiest thing to do is identify who is the base, because then you can figure out what angles or sides are equal. So first of all, if I give you that angles are equal, and then maybe I label a bunch of stuff about the sides. So maybe I say this is 6, this is 6w, this is 2w plus 7, and this is 3w minus 2, something like that. And I could ask you for W, and I could even ask you for the perimeter of the whole shape if I wanted to, and I'll call this M, W, I won't use W, MBQ. Okay, so if I want little w, first of all, because these angles are equal, that makes this the base, which means these two sides are the congruent sides. So now you know which ones to set equal to each other. So I'd have 3w minus 2 equals 2w plus 7. So I end up with w is 9. Okay, so I actually didn't end up using the 6w yet. Now, if I want the perimeter of the whole shape, the whole triangle, I'm going to have to add everything up, which means I will plug in 9. So 6 times 9 is 54, and 2 times 9 plus 7 is 25. And this one is also 25. Now I can plug everything in. So then we finally did use the 6w, right? So we end up with 104 for our perimeter. Okay, so if you know the angles, identify the base, and then the two other are the congruent sides. If you know stuff about the sides, right, then we can talk about the angles. So maybe B, A, D. So maybe I know that the measure of angle B is 5x. Maybe I know that the measure of angle A is y plus 2, and the measure of angle D is maybe 2y. Okay. And I want you to give me y and x, and I could even ask for the measure of angle B, I suppose. Okay, so the first thing I would do is if I know these two are congruent, that makes this the base, which means immediately those two are the congruent base angles. So that means that I know that A and D should be the things I should be setting equal to each other. Now, honestly, I would probably also label my shape. So like I would put the 2y there and the y plus 2 and the 5x. So that's good because it didn't end up using, like I was only using y's together. So I end up with y is 2. Okay. And then I know B is 5x, but I want the measure of angle B and I need x. So this is when I would plug this back in. So now that I know y is 2, that makes this 4 degrees and this 4 degrees, which means, let's see, that's 8. So we have 8 degrees plus 5x. Now all three of those will add up to 180. So I get 5x equals 172. This one isn't going to come out nice, but that's okay. So 172 divided by 5 gives me x is 34.4. Not the worst decimal in the world. And then I could get b by plugging that back in. So 34.4 times 5 gives me 172 for the measure of angle b. Okay. All right. And then last but not least, we dealt with polygons. So shapes that had more than, 3 sides. So like, for example, if I gave you a quadrilateral, and I could label some stuff H, T, U, W, and I could give you like this is, 3x, this is 3x minus 2, maybe 2x, and maybe 2x minus, let's see, 6, 7, 8, 9, 10. Okay, 2x plus 6. Okay. Now, if this was a triangle, I would add up all these angles to 180, but this is a quadrilateral. It has 4 sides. So we have to figure out how much that should add up to. Now, some of you just know a quadrilateral is 360 degrees inside. But if you don't know that, you can do n minus 2 times 180. So in this case, there are 4 sides. And so 2 times 180 is 360. So we know that these should add up to 360. Then you can just add them up. So I could do 2x plus 3x plus 3x minus 2 plus 2x plus 6 equals 360. So let's see. I've got 10x plus 4 equals 360. So 10x equals 356, excuse me. And so this isn't another beautiful number, but it's not terrible. It's not a repeating decimal. So that's x. And then if I wanted the measure of angle W, for example, I would plug in that value for x and solve, right? So I'm just making sure you can do that. Now, if your shape is, say, a pentagon, meaning it has 5 sides, then you're going to have to add it up to 3 times 180 or 540, right? This is if it's a penta, if it has 5 sides gone. If it's a hexagon, what would you have to add that up to? Well, 6 minus 2 times 180 would be 4 times 180, and that ends up being 720, and so on and so forth. So you have to figure out first how many sides, which we call n, and then use your formula to figure out how much the interior angle sum is, right? Like, is it 540 because it was a pentagon? Is it 720 because it's a hexagon? And then you can add things up and plug back in as you need to. Okay, I feel like you're ready. Again, do that review. You can come in tomorrow if you want to come in early because you have questions before the quiz. You can come in at 9:15, and I will happily go through things on your review with you. And I will go through the answers at the very beginning of class so that you can double check those, but we're not going to do any additional review. So make sure that you've got your formulas you want to use for your polygons, and make sure that you understand these ideas with triangles. Okay, guys, have a good one.